Good morning, everyone. My name is Aneela Sajjad, and I am working as a lecturer in Mechatronics Engineering Department, University of Engineering College. Today, we will study about control systems. And first of all, you should know about to the introduction of the control system. For this purpose, we should know about what is system. An interconnection of elements and devices for a desired purpose is known as system. Okay. Similarly, control system and interconnection of components forming a system configuration that will provide a desired response. Means control system is a system that is used to provide the desired response. Similarly, process. The device, plant, or system under control, the input and output relationships. Process is the block that is showing the relationship between the input and output. Control variable, it is the quantity or condition that is measured and controlled. Normally, control variable is the output of control system, like you are controlling the temperature of temperature sensors or controlling the humidity and etc. Manipulated variable, it is the quantity of the condition that is varied by a controller also as the factor of the value of control variable. Okay. Control. Control means measuring the value of control variable of the system, applying the manipulated variable to the system to correct or limit the deviation of measured value from desired value. It means that control is basically you are controlling the value of that variable that is going to be controlled. It is the block diagram. The block diagram is like here. This is the controller and this is process. This is the input set point and this is the output. What are disturbance? Disturbance is basically the unwanted signal or unwanted input of the system. If disturbance is generated within the system, it is called the internal resistance. Similarly, an external disturbance can also be generated outside the system. Okay, it means that two types of disturbance are created in a controller: input disturbance, internal disturbance, or external disturbance. Now we will discuss the types of control systems. Basically, there are two types of control system: open loop or feedforward control, closed loop, or feedback control. This is the block diagram of process. This input is known as disturbance, reference input, measure noise, and this is an input signal, and these are output signal in which you measure the measurement value and performance. Right. Now, the difference between open loop and closed loop system strategies. The difference between the open loop is system does not measure the actual output because there is no correction to make the actual output to confirm between the reference value. Reference value, and this is known as output signal. This is controller and actuator. Actuator will sense the output of controller and then its output will goes to the process. Similarly, in feedback control, the system includes a sensor to measure the actual output and uses its feedback circuit. This is known as sensor, and sensor is acting as the feedback circuit. The example of an open loop control system are electric coaster, standby, gas tube, etc. And feedback or closed loop systems are automated filling ups, steam, magic jar, etc. This controller is constructed based on knowledge or experience. The process output is not used in control computation, but the output is fed back to control computation. In this control or feedback control system, the output is feedback to the input of the control system. Advantages and disadvantages of open loop system. Generally, simpler than closed loop control. Similarly, does not require sensor to measure the output does not or itself introduce stability problem. It means that these are the advantages of the open loop systems, which are simple. They do not require a sensor to value the output. And disadvantage of open loop system is that has lower performance to match the desired output compared to closed loop control. Similarly, advantages and disadvantages of the feedback control system. It's more complex than open loop control system, may have a steady state error, depends on the accuracy of the sensors, may have less stability problem. Similarly, it has some advantages like process control, like well-designed feedback control. It can dispose of unforeseen events like disturbance can occur in that feedback circuit, and it causes to increase the steady state error of the closed loop system. It eliminates the need of human to adjust the control. We need a person, like persons to reduce the workload, give much better performance as compared to open loop closed system. Similarly, here we will discuss some definitions. The definitions are peak time. The peak time is the time required for the response to reach the first peak of the overshoot. And overshoot, what will be the overshoot? Overshoot is when a signal exceed from its targets. Okay. Steady state error, the difference between the desired final output and the actual output. Okay. This is basically known as the steady state error. So this error will be calculated when the system reaches at its steady state position. Now, basically, there are controller. What is controller? Controller is which compares control values with the desired values and has a function to correct the deviation produced. There are basically three types of controllers. First one is proportional controller, derivative controller, integral controller. Proportional controller, P stands for proportional control. With proportional control, the output of the controller will be equal to Kp into E. E output is equal to system output due to proportional control. Kp will be the proportional constant, and E will be the error. The difference between the control variable could be where it is E will be set point minus process variable. E will be the error, steady state error when the system reaches at its steady state position. P controller in a proportional controller to the output, also called the actuating signal, is directly proportional to the error signal. AT will be equal to Kp into AT, where Kp is the proportional constant, also known as a controller gain, and Kp should be kept greater than unity. If the value of K is greater than unity, then it will amplify the error signal. It means that amplifier error signal can be detected easily. This is the block diagram of proportional controller. Here you can see as this is known as difference and set point and process variable. Error will be equal to the difference of set point and process variable. Kc is constant, and this is the bias and output controller. PI controller stands for proportional integral controller. PI controller is mainly used to eliminate the steady state error resulting from P controller. This controller is mostly used in areas where the speed of the system is not a big issue. It is a combination of proportional and integral controller. The equation from the PI controller will be equal to AT is equal to KI integral of error signal plus KP into error signal. Here KP and KI are the constant, proportional constant and integral constant. The diagram for the proportional integral controller would be like this. This is known as the error signal. Error signal will be the difference of set point and process variable. PI controller and controller output. Last one is PID controller. PID stands for proportional integral derivative. A proportional integral derivative is a generic control loop feedback mechanism used in industrial control system. A PID controller attempts to correct the error between the manual process variable and the desired response. And a PID controller normally use proportional controller, integral control, and derivative control. The equation for the PID controller will be Kp into E. E will be error sum plus Ki into summation of error is into delta T, then difference in time plus Kt into delta E by delta T. And output PID will be the output of the PID controller. Kp will be the proportional control gain. E will be the error, and K naught derivative control gain, or delta E into delta will be sum of all past errors, and delta by delta E by delta T are the rate of change of error. Thank you so much.